the convention for putting a direction on this force, because you notice I didn't use any arrows, I just used the magnitude of the force in obvious arguments to say which way the thing goes. Okay, we can formalize it a little better than that. So here, let's just take this 3 Newton force. Okay, now this 3 Newton force is acting down and it's transmitted along that string to this point here, which is at this distance from the axis of rotation. Well, this distance here acts as a fulcrum and this acts as a force, and we have a torque. So it's actually a torque that's accelerating this system. And the direction of the torque is determined by this vector crossed with the force vector. So the moment arm vector crossed with the force vector. So it'd be this vector crossed with this vector gives you a force that we say is in a torque, which is in this direction. Okay? And that makes a certain amount of sense. If we have x, y, z coordinate system here, we have a vector in the negative x direction, we have a vector in the negative y direction. 2 negatives make a positive, and the right-hand rule tells us that this negative and this negative do make a positive in the z direction. Now that's not a force, it's a torque, but you want to get used to the idea that a force in this direction on a moment arm in this direction gives you something that we want to regard as positive. Okay? Similarly, if we wanted to analyze the force of this one, well, moment arm is in this direction, force is here, that's positive x direction, negative y direction, and the moment arm crossed with the force puts us in the negative z direction. Okay, now that's worth remembering when we talk about torques, which is coming up before too much longer, in moments. The upshot in this case is that this positive torque tends to rotate the system in the counterclockwise direction. And this negative torque over here does tend to rotate it in the clockwise direction. So our default direction of motion for a system of this nature is going to be, the positive direction is going to be the counterclockwise direction. And in that sense then, we would say that the 3.1 Newton force is positive and the 2.9 Newton force is negative. So that our net force is 0.2 newtons, and we understand that that means a force that tends to rotate the system in the counterclockwise direction. Okay, then our acceleration, well, is also going to be in the direction of the force in the counterclockwise direction. Our acceleration tends to increase velocity in the counterclockwise direction and or decrease, well, it's not and or, it's either or, tends to decrease motion that's in the clockwise direction. Okay? So that's our convention. You can violate it if you wish. All you have to do is declare, and you need to declare it either way. You need to declare either clockwise or counterclockwise as positive, and then assign pluses and minuses to your forces accordingly.